today we'll be going through PSLE paper 2020 booklet B. Alright? Okay, so the first question is asking us. Okay, the diagram shows a human body. Identify the system and state the function of this system. So the demands of this question requires us to do two things. First, to identify. Second is to state the function. Now, whenever so the system that we over here, clearly this is the circulatory system. This is the easy part. Now, the difficult part is actually remembering what is the function of the system. And this function of this particular system is actually a transport system. So wherever we have a transport, a system that has a transport function, it is very important that we always talk about from where to where. And also, what is the substance that it is actually transporting? Alright? So we have to actually talk about these two things. So let's state the function. So the function of this system is to transport. Now there are many types of substance that the blood transport. The one thing that we can talk about is water and oxygen to all parts of the body. Okay, so if you want to be very specific, alright, you would say that oxygen is from the respiratory system, alright, and water would be from your digestive system actually. When you drink water, it actually goes through your digestive system. Now, what is Y over here? Straightforward, Y is your heart. And then after that, you have other than Y, name another two parts of the system. Okay, sorry, before I move on, I just want to stretch you further by explaining that besides water and oxygen, there are a few more substances that the blood transports. It transports carbon dioxide. It transports waste substances. So what are waste substances? Waste substances are basically things that your body do not need and needs to get rid of. For example, you have things like carbon dioxide is one of it. Besides that, you also have urea, which you need to get rid of as well. Okay, and then you have oxygen. You also have other important things such as your mineral salts. Okay, so what are your mineral salts? Even salt is needed in your body. Magnesium, potassium. So all these things are actually in your blood. Right? But generally, our first thing that we go to is our water and our oxygen, these two. And even things like digested food. These are the three main things that we want to list down when we say when you're asked to list, okay, what gets transported in your blood. And the reason is because, as you know, oxygen and digested food is needed for your respiration. Water is needed for all other process because a large part of your body is in fact made of water. In fact, the main component of your blood, I would say, is water. Okay, then we move on to question C. Other than Y, name another two parts of this system. So this system is the circulatory system. So what are the acceptable answers? Okay, you can say blood vessels. You can say blood itself. Blood is a type of liquid tissue because it's made up of different types of cells combined together. Okay, you can say your artery. You can say your capillary. You can say your veins. Any two of this will give you the 1 mark. Okay, now if you put blood vessels and you put artery, I would strongly recommend that you do not put these two as your answer if you have any choice, because you do realize that artery is a type of blood vessel. However, in this case, I've given you correct. Okay, if you put these two as your answer, I would much rather that you give me blood vessel and blood, because these two are very distinct. Alright, if not, then at least give me artery and capillary, because they are two different types of blood vessels. Next, so the diagram below shows fruit E and fruit F. So whenever you're dealing with fruits, more often than not, especially when they show you a dispersal method, it's got to do with reproduction of plants. So that will give you some idea on what this topic could be. Okay, now when you see a pod, this signals to you that it is by explosive action or splitting action. Now, it's very important to note that it's explosive and not explosion. Some of them, or some of you, in the later question, actually said that this was actually explosion or exploding method. No. So cannot then use the term splitting for, to make sure you don't make that mistake. Now, when you take a look at this, on the other hand, it's got feathery kind of a structure. This will tell you that this is probably wind dispersal. Okay, so that the wind can carry and it can float. Now, how are the seeds E and F dispersed? So this is very straightforward. So E would be by wind, F would be by explosive. Now state one advantage, okay, of the method used by F to disperse its seeds. So F in this case is using explosive or the splitting method. So when you ask question like this, okay, I want to teach you a method of eliminating certain things. The way to do it is to ask yourself, what is the opposite of this method? So this method that F is by explosive, right? What are the other methods? Okay, it will be by wind, or by animals, or by water, correct? So of these three methods, there is not this, which is not wind. Not explosive. What is the difference here? The difference is that the three other methods rely on something. E relies on the wind. If it's a fleshy fruit, it relies on animals, right? But for F, it does not rely on anything for it to actually disperse. Now, do not use the term anything, because it is general statement. It is very vague. Use terms that you already know, such as animals or wind. So the one advantage that would be is that F does not depend on animals, wind, or water to disperse its seed. Right? That's all. So we be specific about this. What is it that you learned? You've learned animals, wind and water. What? So you just state it down. Perfect answer. Next. John conducted an experiment to find if the amount of wind. So when in every single experimental type of question, it is always very good to identify your change variable and your measured variable. However, to my dismay, when I looked at your paper, I did not see this in many of your paper. Your paper was pristine. It was clean. Why is this method important? Is because it helps you clarify what is the aim. Alright? What is the aim of the experiment? And it helps you answer the questions later on. I will explain to you later. Now, John repeated the experiment 5 times with all the factors kept the same, except for one. Suggest 2 possible ways of varying this factor. So remember, because I told you to highlight the change variable, the change variable is actually the wind, right? Amount of wind. So the method that you suggest has got to do with amount of wind. Many of you, about 1/3 of this class, what you did was that you actually stated drop E at different height. Drop E at different height. Are you then changing the correct change variable? No, you are not. And the reason why you answered it wrongly was because you did not bother to take the time to identify, highlight what is the change variable. So the change variable can only be the amount of wind. Some of you even went as far as to telling me change E to something else. That's not right, because I want to know the amount of wind. So what are the 2 methods? And when you suggest a way, you cannot tell me change the amount of wind. If you tell me change the amount of wind, the question that you're answering is, what is the change variable of this experiment? You realize that? Some of you just told me change the amount of wind. But the question asks you, how? State 2 possible ways is how. You tell me. So it will be to increase the speed of the fan. So by increasing the speed of the fan, you are increasing the speed of the wind, right? The amount of wind. The second method would actually be to increase the number of fans, right? So if you started off with 1 fan here, I can have the exact same fan, but I put 3 instead of 1. Then the amount of wind would be different. Okay, now I want you to pause and take a look at your answers. Did you actually bother to take some time to identify what is the change variable, especially those who have gotten this question wrong? Next. The diagram below shows how substances are transported in a plant P and Q. In a plant. P and Q represent different parts of the plant. The arrows represent the movement substances G and H. Now, whenever you do this, okay, always remember this. You want to identify 2 things. One is your roots, and the other is your leaf. Because why? Your roots would be your source of water. So that means it should start from your roots. Your leaves would be your source of food. This is where your food should originate from, because food is made in the leaves and transported to all other parts of the plant. Do you understand? So this is a common question. How to do it? This is how you do it. Now, so I know that my roots are here, right? But I don't know where are my leaves. But I know that since this over here is, this arrow shows that it's originating from my roots, I would know that, this most probably would be water and dissolved mineral salts. Oh, by the way, just in case you didn't know, when you talk about transport of water, mineral salts needs to be part of the answer. It is just not good enough to say that water is transported from the roots. You have to say water and dissolved mineral salts. Okay? Now, then after that, what is G? So you would realize that G is dotted line and it originated from Q. So more often than not, I will already know more or less my G is probably food. And then my Q over here, these are my leaves. Why? Because it's originated from Q. Flowers, the main function of flowers is to reproduce, not to produce food or anything. So it's like the taker of all things. So you will take food from your leaves. It will also take water and dissolve mineral salts from your roots. Okay? So just in case you didn't know, let me explain a little bit. What kind of mineral salts are we talking about? For example, magnesium, potassium. All these mineral salts can be found in your soil, in the natural environment. When it's dissolved in the water, when your plants absorb water, it also absorbs these minerals. What are these minerals important for? They are important for making things like your chlorophyll in your plants. You will learn this in secondary school, but I think it's good that you know a little bit about it so that you form a better complete picture. Alright? So identify parts P and Q. So what is in the center of O? Center of O will be your stem, right? This is your stem. It's the one whereby it connects everything. And your Q will be your leaf. Or leaves for plural. Okay? Next, identify substances represented by H and describe how these substances move in the plant. So H in this case would be, so H is, or I would say is R. Okay, R. Okay. Water and dissolved mineral salts. If you just put water, no marks. This is half a mark. Half mark for mentioning that. Then where is the other half mark? The other half mark goes to is transported. Okay, sorry. Let me backspace. Is absorbed by the roots and transported to all parts of the plant via the water carrying tubes. Of course, if you are good, you would know that watering carrying tubes is also known as your xylem. So how do you mark this? Half mark here, absorbed by the roots and transported to all parts, half mark, via the water carrying tubes, 1 mark. Half mark, 1 mark, 2 marks. Okay? That is the breakdown of how this is being marked. Okay, moving on. Okay, this question, I need you to be very careful. This is the part that some of you could have lost marks. Please check that I have circled it out. If I missed it out, just make sure you take note of it. Oil is sprayed on the stagnant water as shown. Explain how this prevents mosquito from breeding. Okay, so the correct answer is that it prevents your mosquito larva from, okay, from what? From getting oxygen or from breathing. Okay, you see, even when I'm talking, I actually said the wrong answer. Let's rephrase that. It prevents the mosquito larvae or larva from getting oxygen. So the key idea here is if you just put mosquito, wrong. Because mosquito is the adult form. Mosquito larva is the correct one. So remember I once told you that you need to be very careful whether is it and follow exactly what is being stated in the diagram. So you need to be careful like that. So you would say that the mosquito larva is unable to get oxygen from the surrounding for respiration. Okay? Next. Malaria is a disease spread by mosquito A. Children infected with malaria are found to be bitten more often than mosquito A. Okay? Joel wanted to find out if the children infected with malaria are more attractive to mosquito A due to a certain smell. So what is the change variable? Is the change variable infected with malaria or is the change variable due to that smell? The change variable is actually what? Smell. Right? Right? Because he said in his statement, I want to know whether the smell is the one. So it doesn't matter if the child is infected with malaria or not, I don't care. But I want to know, is it because of the smell that is produced by malaria? Okay, so if I'm able to isolate that smell later on, I can use it for other things. If not, when you think about it, if I want a smell in the future, in very extreme cases, I'm going to have to infect something or somebody with malaria. Right? And then obtain that smell. No, that's not what I want. Because then I'll be harming people. No, I want the smell. So he then set up. Okay? Now, this is a question that is very, very iconic for accuracy. I will talk to you why is it accuracy in this case. Now, Joe counted the number of times the mosquito landed on the shirt for 3 minutes. He repeated the experiment using another shirt worn by an uninfected child. State a hypothesis on how the smell affects its attractiveness to mosquito A. So remember, hypothesis is not an aim. Hypothesis just tells you what you think it is. Right? So what's the change variable? The change variable is actually this one. Smell. Right? So my hypothesis would be, it can be, okay, the smell caused by malaria will attract more mosquito A. That's it. That is one hypothesis. Remember, in hypothesis, you can actually have the other one, right? The smell caused by malaria will not cause it to attract more mosquito A. Either of which is correct, because this is forming a hypothesis. That's about it. No right, no wrong. And then you test to see whether your hypothesis is true or false. Okay, yes, but some of you didn't do that. You tell me malaria. Whether malaria will attract more mosquito A. You see, that's where you need to be careful. A number of you is talking about the malaria, or some of you tells me about the fact about the t-shirt. Well, the t-shirt will attract more. It's not the t-shirt. I don't care about the t-shirt. It's the smell. Okay? that I'm concerned, not about the t-shirt, not about malaria, it's about the smell. Next, Joel used a white t-shirt instead of a black one for the experiment. Suggests why using allows him to have more accurate results. So remember, when you deal with accuracy, you're dealing with MV, your measured variable, not your change variable. If it's fair test, it's got to do with your change variable. If it's accurate results, accuracy's got to do with measured variable. Okay, am I clear? So how do you measure, how do you obtain results that is more precise? So in this case, you are counting mosquitoes. Then you ask yourself a question again. Remember I told you the method that I want you all to employ? What happens if you use a black shirt instead of a white shirt? Flip the question around. That will tell you what could be the issue. Flip the question. What happens if he uses a black shirt? He will not be able to see the mosquitoes because the mosquitoes is black. Okay? So then you go, aha, I cannot see mosquito. So by using a white shirt, he will be able to see the black mosquito against the white shirt more clearly. Okay? That's the answer, and count them accurate. So the key thing is to see. The word see must be there. A lot of you say, oh, so to count them more accurately. I think I gave you all correct because they accepted it in the Marcus report. But main point about it is, it's not just count. You're just lifting. If you just say that, you should say see them more clearly when the black mosquito is against the white shirt. That enables him to count more accurately or count more precisely. Okay? Because you can see them clearly. Next, Joe recorded his results in the table. Scientists are now able to store the smell produced by infected people in a container. Suggests how Joel could use this smell and his result to reduce the number of bites on people. So, over here, there are two answers. Okay, I'm going to present to you the two answers. The first answer, it would be to, it is to actually use the smell to attract the mosquito into a trap and kill it. A lot of you didn't tell me kill it. If you trap it and then you release it later, it will still bite people. Okay, that is the main point. So you trap it and you kill it. Okay, a lot of you didn't say kill it. The second point, the second alternative answer would be, okay, use the smell, okay, to lure the mosquito away from, actually far away from the people. The word here is away. So a lot of you say, oh, use the smell to attract the mosquito. But you never say away what? So put the smell next to the person that is attracting the mosquito to the people. No, that's exactly what you all wrote. Take a look at your answer. Use the smell to attract the mosquito. Huh? Then where is the part about it being away from the people? That's the key thing, right? It needs to be away. Okay? So when you answer questions, think in totality. What is the point? The point of attracting the mosquito is to make sure that it goes away from the people, but you didn't state that. You just said, oh, attract mosquito towards the people. Is that what you meant? No, right? Okay? Okay, let's continue. This is part 2 of 2020. Question 33. Bees are commonly found near flowering plants. Describe how bees help plants to reproduce. Now, for this question, you actually need to look very carefully. The keyword here is describe. But many of you just told me, oh, the bees help to pollinate the flowers, which is not what I want. I didn't ask you what did the bees do. I did not ask you to state the process. I said describe. So obviously, you know that the process is pollination. But it's not good enough to just tell me it's pollinating or pollination. I need to see what happens. So in pollination, you know that there are two things that are involved. Your anther and your stigma. And then there is your pollen grains, which is transferred from your anther to your stigma. So you need to tell me that. So what could your answer be? So bees help to transport. Remember, it's a transport function. So I've taught you this umpteen times. From where to where? Pollen grains from the anther to the stigma of the flower. Okay, so what am I looking for? I'm looking for from where to where. Okay, and transport what? Okay, so just telling me pollination, pollinating, not good enough. Next question. Jia Xuan investigated the effect of substance N on bees with two containers R and S, okay, of the same size using a circular cage. So once again, it's an experimental setup. The first thing that you should be looking at is what is the change variable and what is the measured variable. So if you take a look on this, they're talking about two containers. So what's the difference? So the change variable would be that one has substance N and the other does not have. So this is your change variable. Now what is your measured variable? Jia Xuan introduced bees into the cage and closed the opening. She counted the number of bees visited each container for a duration of 3 hours on day 1, 5, and 10. So this part over here is actually your your measured variable. Okay, so basically the aim is you want to know how the substance N affects the number of times the bees visited the containers. Alright? So state how the arrangement of containers in a cage, alright, allowed for a fair test. Arrangement, that is the key word. So arrangement is what? Physical position of your containers. Where is it? So your containers is here and here. So already say fair test already. Means something about it must be equal. I'm talking about position here and nothing else. Alright? So you should realize that, remember I always tell you this, look at key information given in diagrams. They are not there for any other reasons. They're there to hint you. So if the bees enter here, you would realize that the distance is the same. And why you use a circular container, a sphere, is to ensure that the distance from the entrance is the same. Okay? So when you talk about distance, you need to also mention from where to where is the same. Alright? So how would you pen it down? The bees will need to travel from travel the same distance to both containers from the entrance. Right? Okay, so what am I looking for? Point of reference. So just by saying that they are of equidistance, right, does not make sense. Where is the point that they are equal? From the point of entrance here. Next, the number of times the bee visited both containers on day 1, 5, 10 are shown. Okay? And then they show you the key. Describe how substance N affected the number of times the bee visited both containers from day 1 to day 10. Now, the graphs questions are becoming more complex and they are becoming more authentic in PSLE. So when they ask you to describe when you have graphs, the first thing you need to do is to look at if there's any trend and how many trends are there. Usually there will be at least one, if not two trends. Now, many of you just straight away told me that your N will increase the number of bees visiting the container, right? So the one with actually substance N is actually container S. So what you should have done, which I don't see any of you doing it, is to annotate so that you are clear. Now, many of you just straight away say, oh, N increases the number of times that the bee will visit container S from day 0 to day 10. But this is not the case. This is absolutely not the case. If you realize there are actually two trends here. The first trend, which I'm going to use a pink highlighter, is actually the first trend or the first pattern, which is that what? On day 1, substance N has no effect. How do I know it's no effect? It's the same, right? There is no difference in number of the bee visiting N or S. Oh, sorry, R or S. R doesn't have N, but S has. So whether is there N or no N is the same. So this is trend number 1. And then after that, the second trend that you would see, which I'm going to use green to highlight, is that, yes, from 5 to 10, you realize that the bees seems to have a preference, okay, with S. Clearly because this one is higher than this. Alright, so you have to talk about the two trends. You cannot just say from day 0 to day 10. So the minute you say that, the whole question is wrong, because that is not true. Neither the first trend nor the second trend is true, because the first trend only talks about day 1, the second trend talks about day 5 and day 10. So if you say from day 0 to day 10, okay, N actually increases the number or causes the increase in number of bees visiting S to increase, the whole thing is wrong. Okay, so how should you pen it down? So they say describe, right? So the two trends, the first trend would be at day 1, substance N has no effect on the number of times the bee visited the container. And then the second trend would be that more bees visited the containers or the container with substance N on day 5 and 10. Okay? So be very careful when you are looking at your graphs. Alright, the next question, another experimental question. Okay, Jaden placed the same amount of pond water which contain tiny organisms into two identical glass containers, A and B. He painted container B black. So this will more or less signal to me that, okay, painted black, that means no light. No light, no photosynthesis. Okay, now I could be wrong. As in when I am doing exams, right, I could be wrong when I read on the question. But as when I'm reading the question, certain key ideas should pop into my mind immediately, such as black, no light, no photosynthesis. Okay? Besides that, when will you see black? Absorb more heat. Right? These are the instances whereby you can actually think of why black. So sometimes, maybe as you read on, maybe it's not photosynthesis, it's heat. But it doesn't matter. It gives you a bit of idea. Okay, certain ideas should start popping in your mind already to help you understand the question. Then after that, he said that he placed both containers same place under bright light. So when I see the bright light, it confirms that probably it's got to do with photosynthesis, right? And then he measured the amount of oxygen in each container daily. So I see the word oxygen, and then I sort of remember I'm talking about photosynthesis. So then I relate these ideas together. Yeah, okay, it makes sense because it's probably about photosynthesis, because when an organism photosynthesizes, it actually produces oxygen, right? Okay. Now, I just want to caution one thing. Nowadays, PSLE is becoming very authentic. In your syllabus, we usually teach you only plants. Alright, plants can photosynthesize, but in the real world, there are certain other types of organisms. They will contain, they have been found to contain chloroplasts. So even though they're not true blue plants, they can photosynthesize. So I just want to caution you on that. Because in this question, it doesn't matter whether or not these are plants. So, explain why the amount of oxygen in A increased while the oxygen in B decreased. So, there is two parts that you need to talk about. So be very careful. So in your question, you should label 1 and 2 and make sure you fulfill the 2. So now that we've established it's about photosynthesis, we already know that the one in B has no photosynthesis. So since there's no photosynthesis, okay, it doesn't matter which organism, but basically if this organism cannot receive light, it will not be able to produce oxygen. It can only respire. So because it can only respire, then the amount of oxygen that there is in the water should drop. So if you look at it, right, it actually tallies. Amount of oxygen is actually dropping. As opposed to A, whereby it's a clear container, the organism will be able to receive light. So photosynthesis can occur, it will produce oxygen and it will go up. So therefore, okay, it is very important that you actually realize this. Okay? Now, okay, then after that, next, let's pen this down, the first part. So you would need to say that plants in A is able to take in light for photosynthesis. So the idea is that it's able to take in light, and then I must see photosynthesis, producing oxygen. Right? Then the second part, which is B. In B, the plants. Okay. Now we are assuming plants are. You can actually say to be safer. You should say the organisms. Okay, the organisms were not able to receive light for photosynthesis, and hence can only carry out respiration. Where oxygen is taken, when oxygen is used up. So the used up part and the respiration part qualifies the graph pattern, whereby it is actually decreasing. Okay? Next, suggest one possible reason that could have resulted in Jaden obtaining inaccurate results. So wherever you're dealing with inaccurate results, you are actually dealing with the measured variable. Please write this down, very important. So we're really talking about the method or the instrument used to obtain the results. So if you remember in another past year paper, we talked about the mosquito and the white shirt. So the reason why you were able to obtain more accurate results when you use the white shirt was because the mosquito could be seen clearly against the white shirt, the black mosquito. That it was actually a method to obtain your measured variable, which was number of mosquitoes. In this case, we are talking about, okay, the amount of oxygen on a daily basis. Okay. So in this case, you ask yourself, how do you think he actually measured it? So because he did not put in any, okay, form of oxygen probe or data logger, all right, the only way that he could have actually measured it would be to open the lid on a daily basis, okay, when he measured it. So when Jaden opened the lid to take the daily measurements, oxygen could have escaped or entered the container. Now, for this particular question, if you put here the number or type of organisms could have been different, I gave you correct, because that was what was accepted. However, I want to stress that the answer, if you say different types of organisms or different number of organisms, ask yourself this question: are you talking about accuracy or are you talking about fair test? It's very clear cut. It's a fair test answer, because right from your start you have more than one change variable, and that change variable is number of organisms. So if I were to mark this very strictly, different type and different number of organisms would not be accepted. Be very careful. Okay? Most of you actually wrote different number and different type. Next, Sylvia boiled some water in a pot on the stove. State what boiling means. Okay, so when we give you your notes at the back, the consolidated science PSLE notes, there is a whole list of definition. You need to memorize it. When it comes to definition, there is no other way. You have to memorize. Okay? So what boiling means? It means change of state from liquid to gas at a fixed temperature. Now be very careful. Water is not the only type of metal that can boil. Even your gold, your metal gold can boil. Metal can boil. Literally after it melts, if you heat it enough, it will also boil. And yes, pure substances have a fixed boiling point. So that's why you realize in this answer, they did not say it is the change of water from a liquid to gas. It is just simply change of state. Okay? Next, this question was very poorly done because you did not look carefully. Sylvia wanted to cook some egg at 80 degrees Celsius. When the water boiled, she removed the pot from the stove and added some cold water. She then put in some eggs and covered the pots for 10 minutes. And then there's a temperature sensor. The key word here is without reheating the pot. Right? So this is the condition given by the question. But some of you actually said heat the table. But when you heat the table, aren't you also heating the pot in a way? And then some of you said put a heating element inside the water. I'm like, really? Is that what? You did not read this part? You can't do that because you are reheating the pot. Okay, suggest two ways, and they're asking for two ways. Many of you wrote one way for some strange reason. Okay, make sure the water was kept at 80 degrees Celsius in the same pot. So you cannot even change the pot. So some of you say change the pot. Nah, this is what you all wrote. It means that you did not read the question carefully. So what are the two ways? The first way is that you can actually state that you can place a covering or poor conductor of heat around the pot. The second method is add boiling water when the temperature of water drops below 80. Now, I must caution you on this answer. Some of you quite smart. You got this. But unfortunately, you know what you tell me? You don't say add boiling water. You say add water at 80 degrees Celsius. If the temperature is below 80 already, you add 80, it's still going to be below 80. Right? You think about it. So if the temperature drops to, let's just say 70 degrees Celsius, and then you add 80 degrees, won't the water be about 75 degrees? It's still below 80. In order to get it to 80, and if the temperature has dropped below 80, you need to put water that is above 80 degrees. So if you tell me 90 degrees, 100 degrees, answer is correct. So look at your answers. Okay? Next. Rami wrote a metal ball from point X, okay, at low speed past a strong magnet as shown. Explain why the metal ball moved past the magnet. So the fact that it moved past the magnet, it must be because it is a non-magnetic material, not because it's a insulator of electricity. Don't laugh. That's what some of you put. Okay? So the metal is non-magnetic. So what are some examples of non-magnetic metal? Okay, example, copper, aluminium. So just in case you have forgotten what are your magnetic material, remember coins. C-O-I-N-S. Okay, so this two is what? Cobalt. I is iron. N is nickel. S is steel. Okay, I'm writing it down. Please pen it down. You can never be too careful. Next question. He then wrote an iron ball. So iron ball is magnetic, right? In the same direction. Which path will he take? Q, R, S, or T? So can it be Q? Now, if you take a look at it, it cannot be Q. Why? Because when it comes to here, it suddenly went this way, continue the trajectory. That means it went to here and then it got repelled. In order for it to happen this way, firstly, you will need to push the ball in this direction, which is not the case. Secondly, it has to be a magnet. And somehow, the light pole happened to be facing each other and then it got repelled away. So Q is up. S. Okay, S actually is plausible. But how come we don't take it? It's not the best. Because it says strong magnet. And then T is, wow, it's a magnet and then it got repelled away. So leaving R with the most plausible. Why? Because yes, while it's rolling in this way, okay, when it roll past, then it gets attracted what? So it's like a field, there is a trajectory it must follow. If it's so strong, it should look like this. Straight away, it gets attracted. Okay? But that wasn't given us an option. So this is a reasonable option whereby when the point of attraction is strongest here, it causes the ball to curve. So your answer is actually R. Okay? And then what is the answer? So, very straightforward. You will just need to tell me that iron is a magnetic material. Hence, the metal iron ball will be attracted towards the strong magnet. That's about it. Okay, moving on. I shall type a mass to an electric toy train as shown in the diagram. The train moves slowly from A to B. Okay. Now, next, Aisha linked a wagon, so there's one more additional item. When she placed the same mass on the wagon, the train moved faster. So what is the change variable? The change variable is the fact that there is this wagon here. Okay? So now it moves faster. So this wagon has wheels, right? So straight away, what comes to my mind when I think of wheels and moving faster it will be that the wheels actually help to reduce frictional force. Right? So then, even without me looking at the question, I've already got a preconcepted some ideas. Then I continue to read, and then they say, give a reason why the train moves faster when pulling the mass on the wagon. Right? So, very straightforward. There is less friction between the wheels and the track. Okay, as compared to the mass and the track. Right? So one, we're talking about directly having the surface of the mass and the track, and the other one is talking about now the wagon is the mass is on the wagon, and so we're talking about the frictional force between the wheels and the track. Okay, this question. Okay, the train moved from A to B easily, but moved up the slope slowly. Explain why the train moved up the slope slowly. Now, some of you said this. Oh, because when the train moves up the slope, gravity is acting on it. So, you mean only go up slope, the gravity is acting on it. So, down here, no gravity. Your train should be floating like Santa Claus like that. No, don't laugh. This is what you wrote. Remember, as long as you're on Earth, gravity is acting on. Okay? Now, if you want to talk about gravity, what is the key idea? What is the difference when you're talking about this area here and this area here, which is going up? This is going straight, this is going up. The difference is that when you're going on the slope, your directional movement is this way, up. But your gravity is pulling you down. So essentially, you are going against gravity. And that's why you are moving at a slower rate. But most of you said gravity was acting on the train when you move up the slope. You didn't use the word against, you say it's acting on. So what you're telling me is, you mean gravity is not acting on the train over here? The difference is the direction movement of your train once again. Your train is moving up in this area, and this area is moving horizontal. Okay? So what would your answer be? So, very straightforward. Okay? The train is going against gravity. And please don't tell me overcame gravity. You'll be floating. Now, there is an alternative answer. The alternative answer, instead of dealing with forces, deals with energy. When you are moving from point A to point B, okay, you're just going horizontal. But when you are moving upward, some of your kinetic energy gets converted to GPE. So now you have less KE to move. Alright? So this answer I'm giving you is based on forces. The alternative answer I'm giving you is based on energy. Some kinetic energy is converted to gravitational potential energy. So you have less KE now. So you move slower. Now, this question was really poorly done. I believe almost everyone in this class has gotten it wrong. Look at the key words. The train and wagon were linked by plastic rings. Why did they even give you this word plastic? Why cannot be metal? Why cannot be glass? Why plastic? So remember, I always tell you, flip the question, what if it's not made of metal? Plastic. What if it's made of glass? What if it's made of metal? Would it change the outcome? So based on this, you would have realized that, hey, this could be a material question. Right? Remember I told you PSLE questions are very authentic. So, they told you opening plastic ring of wagon is narrower than ring of the train. Okay, so this is ring of the train, and then this is the opening. So because it's narrower, by right it should not be able to pass through. This part that is highlighted in red should not be able to pass through this part that is highlighted in blue, because the gap over here is smaller than the thickness. Okay? So when the wagon was on the slope, it broke loose and rolled downwards. The plastic rings were not broken. Once again, they told you, not broken. How come? So it's got to do with the fact that why is it not broken? Oh, because magic. Of course not. It's not magic, right? Ask yourself. It's got to do with the property of the plastic. It's got to do with the fact that it's flexible. It's able to bend, such as the opening is wider. So ask yourself this question: how could it have broken loose? The only way it could have broken loose is that if this gap here becomes bigger. And the only way that this will become bigger is if it stretches. But it says here it didn't break. So I need a material that doesn't break. And just nice, it's made of plastic. And then they ask you, explain why the wagon broke loose from the train without breaking. Once again, they highlighted this fact, without breaking. So once again, this will tell me it's got to do with the property of the plastic ring. Right? Plastic is something you've learned before, what? How come none of you actually realize that? So what would your answer be? Plastic is flexible. And then you go on to say that opening of the ring is forced open due to the mass or the weight. The weight of the mass. So the mass in this case is the object. It talks about this part. It's called the mass. Why we use weight here? Because what's the difference between mass and weight? Mass talks about the amount of substance used to make something. Weight talks about the amount of gravity that is acting on this mass. So because it is pulling down, see? So then when it pulls down, it forces this part to open without breaking. Okay? Next. Ahmad set up an experiment in the room as shown. There was no wind. He released the wooden strip with plasticine at A gently. So A is here. The plasticine made one complete swing, move from A to B and then back to A. So it's one complete swing. He wanted to investigate how, the mass of plasticine, so this is my change variable, affects the time taken for 10 complete swings. This is my measured variable. His result is shown below. So whenever you see a trend, the first thing I like to do is I like to see this is actually increasing. This is actually, is it increasing? 15, 14, 15.2 is going, is decreasing, increasing, decreasing. No trend. I have no idea more than half the class actually put increase. As the mass of plasticine increases, the time taken for 10 complete swings increases or decreases. That's what you wrote. I have no idea why you wrote that. It is very evident that there is no pattern, but a lot of you, okay, don't believe me? How many of you put here increase or decrease? Raise up your hand. High up. Come on, don't be shy. There's more than that. Okay, hands down. How is this even possible? Look, there's no trend. Okay? State two variables he needed to keep constant for the experiment. Everything under the stars needs to be the same except the change variable. However, when you answer this, can you please be specific? I want you to talk about an attribute of the item. For example, please, where possible, don't tell me things like, oh, make sure you use the same wooden strip. What about the wooden strip? The mass of the wooden strip, the material of the wooden strip, okay? Make sure the same type of strings is being used. Be a little bit more specific. Talk about things like the type of string. Okay, type of string in this case can, because there are different types, right? There are yarns, there is nylon, there is like different types, metallic. So just make sure you be a bit more specific. So I'm going to say thickness of string and maybe mass of wooden strip. So I really want you to learn how to be a bit more specific. Don't just say same type or the same. What of the item? The height, the mass, the weight, the thickness, the material. Okay? Based on the result, state how the mass of plasticine. Okay lah? This is what I want to tell you. Right? So this one, you have to say that mass does not affect time taken for 10 complete swings. And make sure you follow exactly what the change variable and measured variable as stated in the question. Don't take the shortcut. Because if you take the shortcut, some of you will just say, oh, mass of plasticine does not affect the time. Next, suggest one improvement to the experiment to obtain more accurate results. You should say that what is your accurate results? What has got to do with MV, right? What are you measuring? You are measuring the timing, correct? So this one, you can say that use a digital stopwatch to measure the time. Alright, accuracy. If it's reliability, then you repeat the experiment at least 3 times and take the average. Okay? Question 39. Okay, Peter built a door lock as shown. When he closed the switch, the iron bolt moved to the right. Okay, to the right is this way, away from the catch. The catch is here. So this unlocks the door. State why copper, a type of metal, is used to make wires. Please, it's not because it's a magnetic. It is copper is a good conductor of electricity. Right? Then you can allow your electricity to pass through. Explain how the door was unlocked when Peter closed the switch. So when doing this, you always trace in order to help yourself. So when it's closed, what will happen is if you see coils and if it's a metal, this part, okay, more often than not will become a electromagnet. So when that happens, because this is an iron bulb, it is made up of magnetic material, okay, it will be attracted to your magnet. So when that happens, it pulls back in this direction until over this. So now you can open the door. Alright? So this is actually a CEO question. So what would you say? So you would say that when the switch was closed, the circuit is closed and electricity can flow through the circuit. Then after that, you would say that metal cylinder, correct? This metal cylinder becomes an electromagnet and attracts the iron bolt. Okay, so this then becomes unlocked. So C is where circuit is closed. This is your C. E is where electricity can flow through. And last one, your outcome, O is here, CEO. So when Peter opened the switch again, he found that the bulb did not go deep enough into the catch and locked the door properly. Without changing the iron bulb, suggests changes to his setup so he can lock and unlock the door properly. This question was so poorly done. A lot of you think that this spring is like a gun. Literally, okay, you told me, oh, use a stiffer spring. So now it can, when you use a stiffer spring, wow, amazing. Now, because you compress it more, right, need more force to compress it. Wow, then the elastic spring force also shoot the bolt this way. Pum. Excuse me, it doesn't work that way. Your spring is just acting as a support. That's it. That's it. You just need something to support it. The whole idea of a spring is not to shoot the ball out. It's not to propel it forward. No. So what you should have done is just use a longer spring to stop. So when you use a longer spring, it will actually, when you actually release it, it will cause it to push your bolt further in. You did not change the length of your bolt, but you changed the length of your support. That's about it. The spring is not there meant to propel it or to shoot it. No, it's not. It's just to gently push the bolt in. That's all. It's actually stuck to it. It's stuck to it. Okay? Now, then after that, that is actually to lock. The second point is unlock. How to unlock it? Now that you have a longer spring, it's longer, right? So in order for it to work, you need a stronger electromagnet, because in the distance between your bolt and your magnet has now increased. So the only way to solve it is to have a stronger magnet. So what can you do? You want to actually coil it more, correct? So to lock, okay, To lock properly, he can use a longer spring which allows the bolt to move deeper, okay, into the catch. And then what about to unlock properly? Now that we use a longer spring, to unlock properly, he can coil more wire or rounds of wire around the metal cylinder, causing it to become a stronger electromagnet. Now there is actually an alternative answer, that is to use more batteries. Because if you add more batteries, this part is also valid. You have a stronger electromagnet. Okay, so the final question for this paper, John packed a pack of brown sausages wrapped in a clear plastic from the freezer onto a table. After a short time, a thin layer of white solid was formed on the surface of the plastic wrapping. Okay, now, nowadays, PSLE, right, they always test very authentic questions like these. So when you look at it, ask yourself some question, okay, what could it be? So keywords, you see things like freezer. So what will a freezer do? So a freezer means that it's got to do with very low temperature. And then the word freezer also probably tells you that it has got to do with freezing. And then you ask yourself which topic has this keyword freezing. And it will tell you states of water. So this would more or less tell you that it's got to do with changes of states of water topic, probably remote water cycle. So it tells you that after some time, a thin layer of white solid was formed magically. So obviously things cannot just happen, right? So roughly you would know that since the word freezer or freeze is there, it's got to do with water, and probably it's got to do with the topic on water cycle. So this thin layer of white solid, think about it. What could it be that is white and is solid, right? So when you think about it, what comes to my mind when it's related to water is actually ice. The fact that you can see it means that it cannot be water vapor, okay? And if it's a solid, it cannot be liquid water, so it's actually ice. Now, why would it even form on the packaging of this brown sausage? So, in the first place, in order for ice to form, you need water to freeze. Where did the water come from? Did it come from the packet of sausage in the freezer? The answer is actually no. What actually happened is that in the air that you will not be able to see is your warm water or warmer water vapor. Okay, as compared to your very cold sausage that came straight from the freezer. So when these warmer water vapor touch the surface of your sausages, they will lose heat to it and they will condense to become tiny water droplets. So the packaging of your sausages is actually the cooler surface. Now, Once they become tiny liquid water droplets, alright, the next question you will ask me, but Mr. Chong, isn't this liquid water droplet? Yes, you are right. However, don't forget, these sausages came from your freezer. So because it came from your freezer, you have to understand, in reality, nobody sets their freezer temperature at 0 degrees Celsius, even though 0 degrees Celsius is the freezing point of water. In reality, we are looking at temperatures like maybe negative 8 degrees or negative 13. Some people even put it at negative 25. So anything that is below negative 25 degrees is called deep freezing. And this is what they use on fishing boats. So for example, if you're in Alaska and you are catching some fish or some seafood, they will actually have a freezer on board the ship. So immediately after catching the seafood, they will dump it into this seafood and then they will deep freeze it at minus 25 to actually really deep freeze the seafood to keep it the freshest. So we're all looking at temperatures that is way below 0 degrees. So which means that when your sausage first came out, it will not be at 0 degrees. It will probably plus minus maybe say negative 5 degrees Celsius. So given the fact that it's negative 5 degrees Celsius, it is still lower than 0 degrees, which is below the freezing point of water. So therefore, the tiny water droplets that were just formed from condensation would have lost heat further to your sausage and it freezes to become your white solid. I'm using pink, but it's actually white, because if I use white, you all cannot see anything already. Okay, white solid that you see. And that was actually what happened. Okay, now when I was marking your papers, most of you could understand, but some of you could not. Those of you could understand, you got the general direction of your question correct. However, you failed to mention the direction of heat loss. Okay, heat loss. And some of you told me something like the white solid formed because the water evaporated. So be very careful. You need to tell me where the heat was being lost. That is very important. So let's pen down our answer. So first things first, the first part is talking about how your water droplets form. So the first part, I'm going to use blue because for water. So water, or to make it more succinct, okay, warmer water vapor in the air touched or came into contact with the cooler surface of the plastic wrapping, lost heat and condensed into water droplets. Okay, so this is the liquid water part. Then the second part, I'm going to use pink color, is talking about how the white solid is formed, which is ice. Okay, the water droplets then lost heat to the plastic wrap and froze to become ice. Right, so it's a two-step process. From gaseous to liquid, that's process number 1. From liquid to solid, process number 2. Next, the white solid cannot be seen after a while. Explain why. So they're talking about the white solid. They are not talking about your liquid water. So the answer here is that the white solid melted. Is as simple as that. But some of you told me that the white solid actually evaporated. That's actually a wrong concept because it's a solid, it cannot evaporate. So though some of you were thinking was that, oh, first it melted, then it become liquid water droplet, and then from the liquid water droplet it actually evaporated. Okay, but because they are specifically asking for the white solid, you have to tell me what is the immediate process that caused it to not be able to be seen, the white solid anymore, and that's melting. Okay, the white solid melted.